In this video lecture, we're going to discuss Chapter 4 of The Design of Everyday Things by Don Norman. In particular, this chapter is about constraints. Before we talk about constraints, though, let's review the past things that you needed to know from this book. In particular, we're talking about human-centered design. That's at the core of everything we're doing here. Remember, we want to focus on what people want and what people need. The designs that you make, whether you are an interactive designer or a technical communicator or an engineer or what have you, anything at all, you need to make sure that you put people at the center and focus again on what it is that they want to do, want to have, and need to do. Human-centered design is interdisciplinary. It's not just locked in TechCom. It's not just locked in interaction design. There's all sorts of psychology to it. There's all sorts of engineering to it. Any field you can use in human-centered design. You also need to understand how the mind works and how people live in their actual worlds before you can design anything successfully. Here's some vocab terms you need to know. Remember affordances, signifiers, constraints, mapping, feedback, conceptual model, system image, the double diamond design model and its 4 stages: discovering, defining, developing, delivering. The human-centered design process, its 4 stages of observing, ideating, prototyping, and testing. Also remember these terms: activities, tasks, the gulf of execution, the gulf of evaluation, the 3 different levels of processing: visceral, behavioral, and reflective, and the sequences of actions to bridge the gulfs of execution and evaluation: forming goals, planning actions, specifying action sequences, performing those actions, perceiving the state of the world, interpreting those perceptions, and comparing those perceptions to the goal state. So that's enough with the review. Let's move on and talk about the new stuff: constraints. What is a constraint? It's a limit on a possible operation. It's saying, no, you can't do this, or you shouldn't do this, or you should slow down, something of the sort. The big idea is that you're going to, as a designer, restrict what that user can do with the object or interface or system that you are designing, and you're also going to limit what that user can do in behaving in an unfamiliar situation. Remember, a person who's an expert user of a bad system can probably use it very effectively and very quickly. But you want to design for people who are new at things in particular, because you want to make sure that they have a positive experience going through the system, using it, and they will want to come back and they will use it happily. There are 4 different classes of constraints we're going to discuss. There are physical constraints, cultural constraints, semantic constraints, and logical constraints. We'll talk about each of these in turn. Let's start with the different types of constraints. Let's break these down into material and functional. So material constraints, as the word material may indicate, are physical limits. They put handcuffs on, let's say, and you can reach out and touch whatever that thing is that is the physical limit. It's not abstract. Now, when I say reach out and touch, it may be on a computer screen, so you can't actually reach out and, for example, touch those handcuffs. But you understand that you actually cannot proceed. The user cannot move on. The user cannot do something with a physical constraint. Then we have functional constraints. These are more conceptual. So, for example, the elderly hippie couple here. They don't have the same conceptual limits that you and I have. They're probably into doing a lot of fun things and being free and singing and dancing, you see? So they have fewer conceptual limits than we do. When you design a system, you can always build in some sort of conceptual limit so that your user will feel constrained. Let's talk physical constraints. These, as we've discussed already, are physical limitations. They're material. So they work best when the user can see and interpret them very easily. These things include what we call forcing functions. Forcing functions are, and I'm going to read this to you, I apologize, quote, a form of physical constraint in which the actions are constrained so that failure at one stage prevents the next step from happening." End quote. That's on page 141. There are three different types of these physical constraints. We've got interlocks, lock-ins, and lockouts. So first off, let's talk interlocks. Interlocks force operations to take place in a specific sequence. You must do A, then do B, then do C. There's something happening, whether it is a physical object or a piece of software, something is going on that people have to act in a certain sequence. It's also, an interlock is going to prevent unattended operations, so machines can't run on their own, which could be dangerous sometimes. The classic example is the quote-unquote dead man's switch. The idea here is that the user has to apply pressure or click the button every couple of seconds, something of the sort that the user, the computer, the system, the machine, quote-unquote, knows the user is there and will keep running. Another example that you may be very familiar with is the humble lawnmower. In particular, that thing right there. This is a government-mandated safety device, so once you start up the lawnmower, you don't just let it run. You've got to pull that wire into the handle, and if that wire is not held to the handle, the lawnmower just will not run. I remember when these became new on lawnmowers, and my dad, he had the lawnmower, and what would he do? He'd take a piece of rope, tie that thing down, and just let it be because he didn't want to have to restart the mower every time he took the bag off. So, these things can be defeated. Try to design them so that they cannot be defeated. Next up, let's talk lock-ins. Lock-ins keep operations active. They're in a sense, they're the opposite of lockouts, and well, they are the opposite of lockouts. I'll define this more clearly later. The big idea here is that you want to prevent a user from stopping prematurely or from quote-unquote leaving a system. So, an example of a lock-in that you're very familiar with, undoubtedly, is this dialog box. Are you sure you want to quit? You actually have to go out, click yes, I want to leave, or no, oh no, I didn't mean to, I'm going to lose my hour of work. So lock-ins can be very helpful. Lock-ins can also be sort of annoying for users. For example, you all familiar with this company, right? Well, what Apple does is they put their users in a jail of sorts. Once you start using Apple products are not really easy to migrate over to PC. So once you're in the Apple ecosystem, there are all sorts of different devices you can use. For example, there's the Mac computer, there's the iPhone. Once you've got your music on iTunes, it's there. So once you, there's a forcing function going on here that Apple is actually locking you into their system of computers. So once you start down the Apple path, it's hard to escape. Then we have lockouts. Lockouts prevent users from going in dangerous places or prevent dangerous things from happening. So sometimes these things can be as easy as a literal lock on things, perhaps a tag. Maybe it'll be a pop-up on the screen, and you have to, for example, you're likely familiar with trying to do something on a computer, and your computer tells you you need admin access to do that. That's a kind of lockout. In terms of preventing dangerous things from happening, y'all familiar with table saws? So one of the dangers of table saws, and this thing, you'll notice there's no blade guard on this. You are not supposed to operate a table saw without a blade guard. That's really, really dangerous. That's how people lose fingers. But there are modern table saws that will actually, as soon as they detect any sort of organic material, for example, that hot dog there, what this person is doing is demonstrating that as he pushes it through and the blade touches the hot dog, there will be a safety catch that pops and it will stop the blade instantaneously. It'll prevent that person from cutting off their finger. So that is a different kind of lockout. We also then are moving on to cultural constraints. These are the more functional constraints and not the physical, material constraints. Cultural constraints are sets of allowed actions for social situations or working with objects, usually in a social situation. These are based on conventions. They are arbitrary. There is no particular reason that you must always blank, but it's just what the people do in their culture. Think of the word we used before, schemas. When we work through the world, we encounter objects, we learn how the world works, and we develop a quote-unquote mental schema, a mental map, a mental model of how the world works. That is what cultural constraints are based on. So, for example, what we've got here are instructions for using chopsticks. Some of you may have never used chopsticks before. Some of you may have grown up using chopsticks from the very moment, not quite the very moment you were born, but as soon as you were able to hold them and feed yourself, instead of being given a fork or a spoon, you were given chopsticks. You learned conventions, cultural constraints about how to use these. I remember the first time that I ever used chopsticks. I was served a plate of, what were they? A plate of shrimp at a Chinese restaurant. I was a little kid. I couldn't manipulate 2 sticks at one time, so I just took it like a skewer, stabbed the shrimp, stuffed it in my face. Would that have been acceptable as a child? Sure. People realize kids are not exactly, well, kids are clumsy. We don't have the physical dexterity. But then what if you're an adult and you were given, right now, at your age, you are going to say a Chinese restaurant for the first time, you are given chopsticks and you use it and stab things. Would that be culturally acceptable? The answer is no. So when we start talking about ways to behave with objects in social situations, these are where cultural constraints come into play. You need to figure out what's going on, where am I, what am I allowed to do. We have semantic constraints as well. They're very similar, but the idea is that limits are based on situational meanings. So based on the knowledge of the situation, knowledge of the world, things will give you different meanings. So, for example, we have 2 people here, Matthew McConaughey and Ronnie James Dio. They're making very, very similar symbols with their fingers, but what is going on? Are they saying the same thing? Are they doing the same thing? No, they are not. On the left-hand side, Matthew McConaughey, he's giving the hook 'em horns symbol. On the right, Ronnie James, well, Ronnie is giving it's the evil eye symbol. So, even though these are very, very similar, they have very different meanings. At the one, if you do the fingers up with the back of the palm toward somebody, hook 'em horns. Turn it around, heavy metal. So this is a semantic constraint. If you did one in the wrong situation, it would be it would just be inappropriate. So if Matthew McConaughey turned his hand around, it would seem a little strange. If Ronnie James Dio turned his hand around, it would likewise seem a little strange. Then we have logical constraints. These are based on, are you ready for it? Logical relationships among items. Some of the things people might say is, for example, a logical constraint is I have this piece. Well, it doesn't go here, it doesn't go there. It must go in the empty spot. Or perhaps, as a classic example, the instructions. They say push 5 buttons. I only see 4. There's got to be another one down here somewhere. Maybe I ought to scroll on the screen. Now, ideally, that's a really bad idea to make your user think, well, I've got to go looking for it. Again, bad design, but it's a good example. Another thing that you want to know about logical constraints is they're often related to mapping. So here's a good example of what we're talking about. We have poor mapping on the left and good mapping on the right. If you look at on the left there, that stove, which of those buttons or which of those knobs turns on which burner? Well, let's see. Gee, it doesn't. I could start at the top and then work my way around. I don't know on the left. On the right, though, it's immediately obvious. So there are logical constraints as well happening here in our terms of our design. We're going to quickly look at Chapter 3. You were not assigned to read it, but some ideas from it that will be useful to you. Knowledge appears in 2 places. It appears in the world and in the head. So in the world, we perceive affordances. We perceive signifiers. There are mappings that indicate what's going on, and there are also physical constraints that prevent us from doing things. In the head, we've got our conceptual models of how the world works. We have cultural, semantic, logical constraints on our behavior, and we also have analogies with familiar things. There's a word called skeuomorphism, which is interesting, but I'm not going to assign it. You might want to look it up on your own. It was mentioned in chapter 4 toward the end. Why do you need to know these ideas? The big deal is that when we design things, we ask people to change their ideas and behaviors. But people don't like change. They're familiar with comfortable, familiar things. They are unlikely to want to bust out of their grooves. That's why we end up with legacy problems in design. For example, batteries that only fit in one way. USB plugs that only fit in one way. Matter of fact, the person who designed this original USB plug, that person has publicly said, you know what, we should have taken the time and made it so you can flip it back and forth. It doesn't matter which way it goes. How many of y'all have tried to plug one of these things in and got it wrong every time? Yes, that's me too. We also end up with legacy problems like the inch, the foot, the pound, things that are not used by anybody else around the world. So, yay for America, we have massive legacy problems with our measurement systems. Because, why? Resistance to change. So let's review what you learned today. You learned a definition of constraints. You learned about the difference between material, that is physical, and functional constraints. You learned about 4 classes of these constraints, which are physical, cultural, semantic, and logical. And you learned about 3 different types of forcing functions: interlocks, lock-ins, and lockouts. That'll do for today. Next time we come back with a video lecture, we'll discuss Chapter 5.